This is the EdExcel GCSE 9-1 Maths Paper 2 from the November 2017 series, and it's from the higher tier and it's a calculator paper. Question number 1. We have to solve 5x minus 6 equals 3 lots of x minus 1. Well, first thing we can do is expand the brackets on the right hand side. Currently on the left hand side we have 5x minus 6, and if we expand the brackets on the right hand side, 3 times by x, that gives 3x, and 3 times by minus 1, that gives minus 3. So we have 5x minus 6 equals 3x minus 3. And now if we subtract 3 from both sides, we've got 2x minus 6 equals minus 3. If we now add 6 to both sides, you will find 2x to equal 3, and dividing both sides by 2, you will find x to equal 3 over 2. So we have x equals 3. Question number 2. Emily buys a pack of 12 bottles of water. The pack costs £5.64. Emily sells all 12 bottles for 50p each. We have to work out Emily's percentage profit. Give your answer correct to 1 decimal place. First of all, 50p is the same as £0.5. So 50p is the same as £0.50. Now, if she sells all 12 bottles of water for 50p each, that means she sells 12 times by 0.50 worth of bottles. In other words, she sells £6 worth of bottles. Now, the entire pack costs £5.64, and therefore the total profit this is equal to £6, take away £5.64. Of course, we get £0.36 for the profit, and therefore the percentage profit is equal to 0.36 divided by 5.64 multiplied by 100. So if we work this out, we get 0.36 divided by 5.64 multiplied by 100. It turns out we get 6.38 etc. %, which to 1 decimal place we've got 6.4% to 1 decimal place. So therefore we have 6.4% given to 1 decimal place. Question number 3. As Meet walks once round a circle with diameter 80 meters, there are 8 points equally spaced on the circumference of the circle. Part A, we have to find the distance as Meet walks between one point and the next point. First of all, if we split the circle up into 8 parts, you can see that there are 360 divided by 8 which is 45 degrees between each point. So between each point we have 45 degrees. Now the circumference will be given by pi times by the diameter. Now for us to find out the distance between one point and another point, of course we have an arc length which we need to find out, and that's given by theta, which is 45, divided by 360, multiplied by the circumference, which is pi times by the diameter, which is 80. So if we work this out, we get 10 pi meters. So if we were to round this to 3 significant figures, of course 10 pi, that's equal to 31.4 meters. So we've got 31.4 meters correct to 3 significant figures. So we have 31.4 meters correct to 3 significant figures. And now for part B, 4 of the points unmoved are shown in the diagram below. As Meet walks once around the circle again, has the mean distance that has Meet walks between one point and the next point changed? You must give a reason for your answer. So the total distance of the circumference has remained the same, and therefore the mean distance will also remain the same. Question number 4. There are only blue cubes, yellow cubes and green cubes in a bag. There are twice as many blue cubes as yellow cubes and 4 times as many green cubes as blue cubes. Hannah takes at random a cube from the bag. We have to work out the probability that Hannah takes a yellow cube. So first of all, if we think about the ratio of blue to yellow to green, then there's twice as many blue as yellow. So we've got 1 to 2 for the ratio of yellow to blue. And there's 4 times as many green as blue. So therefore green will be 2 times by 4, which is 8. We have to work out the probability of taking a yellow cube. Well, we've got here 11 in total. 2 plus 1 plus 8 of course is 11, and of those 11, one of those is a yellow, so the probability is equal to 1/11. So we have 1/11. Question number 5, we've got shape T over here, and we have to rotate shape T by 180 degrees about the origin, and then we have to label this new shape A. So here, if I rotate T by 180 degrees, then we've got something looking like this. So if I join these points up, here we've got shape A. And then for part B, we have to translate shape T by the vector -1, -3. Well, if we pick any point, say this point, we're going -1 to the left, and then 1, 2, 3 3 down. So if I draw the new shape, we've got something looking like this. So here we've got shape B. Question 6. We're given that p to the 3 times p to the x equals p to the 9, and we have to find the value of x. Well, because we have the same base here, and we're timesing, we can add the powers. Of course, we're using the rule of indices. A to the power of m times a to the power of n equals a to the power of m plus n. So here we've got p to the power of 3 plus x equals p to the power of 9. And now comparing the powers, we've got 3 plus x equals 9, and therefore x equals 6. Now for part B, we've got 7 squared to the power of y equals 7 to the power of 10. We have to find the value of y. Well, here we have to use the law of indices. A to the power of m to the power of n equals a to the power of mn. When we have a base to a power to another power, we multiply the powers. So here, if we multiply the powers on the left hand side, we would have 7 to the power of 2y, and this is equal to 7 to the power of 10. And if we now compare the powers, 2y is equal to 10, and therefore y is equal to 5. So we've got y equals 5. And now for part C, we've got 100 to the power of a times 1000 to the power of b, which can be written in the form 10 to the power of w, and we have to show that w equals 2a plus 3b. Well, over here, we've got 100 to the power of a times by 1000 to the power of b equals 10 to the power of w. And using the laws of indices before, well, first of all, we need to get the bases the same. And if we get the bases the same, 100 is the same as 10 squared. So we've got 10 squared to the power of a multiplied by 1000, which is 10 cubed, to the power of b. And then we've got 10 to the power of w. If we now use the laws of indices from before, first of all, base to a power to another power, we multiply the powers. So here we've got 10 to the power of 2a times by 10 to the power of 3b equals 10 to the power of w. And now with the same base, when we multiply, as we mentioned before, we add the powers. So here we've got 10 to the power of 2a plus 3b on the left hand side. On the right hand side, we've got 10 to the power of w, and therefore comparing the powers, you can see w is equal to 2a plus 3b. Question 7. ABCD is a trapezium, and that's what we see here. And we have to work out the size of the angle CDA. Give your answer correct to 1 decimal place. So we need to work out the angle shown here. We'll mark this angle as theta. So for us to work out what this angle theta is, we need to form a right angle triangle, as we see here. So if I form a right angle triangle, here is our right angle triangle. And if I know any two lengths, then I can find the angle theta using trigonometry. Now, of course, this length over here is equal to 6 centimeters. It's parallel and equal to this length here. So we have 6 centimeters here. And we can find out what this length over here is too. To do that, we can find out what this length here is. So if we draw out a triangle, we have the 7.5 centimeters here, the 6 centimeters over here. So we can find out this length using Pythagoras. Let's just call this length x for now. So through Pythagoras, x squared plus 6 squared equals 7.5 squared, and we need to find out what x is. Well, if we find out what x squared is, that's equal to 7.5 squared take away 6 squared, which is 20.25. So x squared is equal to 20.25, and therefore, if we find out what x is, we can square root this, we get 4.5. So we have 4.5 centimeters here. So let's add this to the diagram. We have 4.5 centimeters over here. And therefore, for this length is equal to 24, which is the entire length, take away the 4.5, take away the 10 centimeters. So here we get 9.5 centimeters. So here we have 9.5 centimeters. Let's draw a triangle to help us find out what this angle theta is. So here we've got the 9.5 centimeters. Of course, we've got a right angle here. Here we've got 6, and we're finding the angle theta. So we've been given the opposite, we've been given the adjacent. What connects those is tangent. So tan theta is equal to the opposite, which is 6, over the adjacent, which is 9.5. And if we find out what theta is equal to the inverse tangent of 6 over 9.5, which is 32.2, etc. So we've got 32.27, etc. So therefore the angle is equal to 32.3, correct to 1 decimal place. Question number 8. We have to use our calculator to work out the square root of sine of 25 degrees plus the sine of 40 divided by the cosine of 25 degrees minus the cosine of 40. So, on our calculator, if we type that in, we've got the square root of, and then if we type in the fraction button, we've got sine of 25 plus sine of 40 divided by cos of 25 minus cos of 40. Of course, our calculator is in degrees. It turns out over here we get a value of 2.756,03957. And now we have to write our answer to part A to 2 decimal places. Well, if we take a look at the second decimal place, that's the 5, the digit after is 6, which is 5 or greater. So this 5 over here, we need to round up to the next value. Of course, we get 2.76, correct to 2 decimal places. Question 9. Yesterday it took 5 cleaners 4.5 hours to clean all the rooms in a hotel. There are only 3 cleaners to clean all the rooms in the hotel today. Each cleaner is paid £8.20 for each hour or part of an hour they work. How much will each cleaner be paid today? Well, let's take a look at the situation yesterday. If we take a look at the situation yesterday, there's 5 cleaners and they take 4.5 hours each to clean the hotel. So therefore, with this information, we can find out how many hours it took to clean the whole hotel. So we've got 5 multiplied by 4.5. So if we work this out, we get 22.5 hours. What does this represent? Well, it would represent the number of hours to clean the whole hotel. Let's now take a look at the situation today. So for the situation today, they take the same number of hours to clean the entire hotel, so that will be 22.5. And because there's only 3 cleaners, we divide this by 3, which tells us that they took 7.5 hours each when cleaning the whole hotel. And they get paid £8.20 for each hour or part of an hour they work, so therefore the salary will be £8.20 multiplied by, well, here we'd have to round the 7.5 up to the next hour, which is 8. So we round the 8 up to the next hour. So if we work this out, we get £65 and 60 pence. So we have £65 and 60 pence. Question number 10. Here is part of a distance time graph for a car's journey. So we've got the time and we've got the distance. And for part A, between which 2 times does the car travel at its greatest speed? Give a reason for your answer. Well, first of all, we should know that speed is equal to distance over time. So when we come to think about which times gives us the greatest speed, we want the distance to be the greatest but the time to be the smallest. In other words, we want the steepest gradient, and you can see the steepest gradient is in between 0 and 20 seconds. We cover a large amount of distance in a relatively short amount of time. So therefore, we have in between 0 and 20 seconds because this time interval has the steepest gradient. And now for part B, we have to work out the greatest speed, giving our answer in meters per second. Well, here you can see the distance is 360 meters, the time is 20 seconds, and therefore, for the greatest speed, we have here 360 meters divided by 20 seconds, and working this out, we get 18 meters per second. So we have 18 meters. Question 11. The pie chart gives information about the ages in years of people living in 2 towns, Adley and Bridford. And that's what we see here. And what's important to note is that the diagrams have been drawn accurately. So, what we have to do in this question is, well, we've been given the ratio of the number of people living in Atley to the number of people living in Bridford is given by the ratio of the areas of the pie chart. And we're asked in this question, what proportion of the total number of people living in these two towns live in Atley and are aged 0 to 19? Give your answer correct to 3 significant figures. Well, if the diagrams have been drawn accurately, what we can do in this question is, well, if we go back, let's look at what we're finding. We're looking at the proportion of those who are aged 0 to 19 and those who live in Atley. So if you go to Atley and then aged 19, we're looking at this category over here. Now, first of all, let's find the radius. You can see that the radius is 5 centimeters here. So we've got 5 centimeters for the radius of the pie chart for Atley. So the radius is equal to 5 centimeters, and therefore the area, this is equal to pi lots of 5 squared, which is 25 pi centimeters squared. And if we take a look at Bridford, well, if we go back here and find the radius, you can see here the radius is 4. So the radius is equal to 4 centimeters, and therefore the area here is equal to pi lots of 4 squared, which is 16 pi centimeters squared. Now, we're questioning the proportion of the total number of people living in these two towns who live in Atley and who are aged 0 to 19. So, well, the total number of people will be given by the sum of the two areas. So the total number of people will be given by the sum of the areas. So therefore the total area is equal to 25 pi plus 16 pi, which is 41 pi centimeters squared. Okay, so this 41 pi centimeters squared represents the entire population. So the 41 pi centimeters represents the entire population. Now, we need to find the proportion of those who live in Atley and who are aged 0 to 19. Well, of those aged 0 to 19, well, if we look at Atley 0 to 19, we can find out the angle over here. So here, if we find out the angle, let's just find the angle here. Well, this will clearly be 70 degrees because we've got 20 degrees to the horizontal here. Here we've got 0 degrees, so this angle here is 20, so this angle must be 70 because 90 take away 20 is 70. So we have 70 degrees here. Okay, so here we've got 70 degrees. So if we go back here, let's just write that down. We've got 70 degrees here. So how does this help us? Well, from this we can find the proportion of those living in Atley and who are aged 0 to 19. So we're finding this proportion of the total. So here, of those who are oddly, that's going to be out of 360, and 70 degrees of those will be aged 0 to 19. So therefore, for the proportion, we've got 70 over 360 multiplied by, well, we've got the total area, which is 41 pi, and we've got, of those who are oddly, that will be 25 pi. So 25 pi over 41 pi would be those living in oddly, and of those living in oddly, we've got 70 degrees, which represents the age of 0 to 19. Perhaps if I write this down in blue, this here will be the proportion. So if we work this out, we've got 70 over 360 multiplied by 25 over 41. Of course, the pi's just cancel, so we're left with, rather here we've got 41. So we're left with 0.119 to 3 significant figures. So we've got 0.119 given to 3 significant figures. Question number 12. RS and ST are two sides of a regular 12-sided polygon. RT is the diagonal of the polygon. We have to work out the angle STR. Well, because over here RS equals ST, we can therefore conclude that the triangle RST is isosceles. So we've got an isosceles triangle, so that means that this side is equal to this side, and this angle here is equal to this angle here. Now we can find out this internal angle RST of the 12-sided shape by first of all finding the external angle. So if we find out the external angle of the 12-sided shape, then we've got 360 divided by 12, which is equal to 30. So the external angle of this 12-sided shape is equal to 30 degrees. We've got 30 degrees here. And therefore, we can find out the internal angle of this 12-sided shape. That will equal 180 minus the external angle 30 degrees. Of course, we get the internal angle being 150 degrees. We have 150 degrees here. So we've got the external angle being 30 degrees. We've got the external angle being 150 degrees. Okay, and also, let's just keep the colours consistent. RS equals ST. Now, what we can also conclude, because we've got a isosceles triangle, we can therefore conclude that the angle SRT equals the angle STR. So therefore, well, if we write this down, STR equals RST, because the base angles in an isosceles are equal, we can conclude that STR, rather if we just move this here, we can therefore conclude that this angle is equal to 180 minus the 150 over 2. So if we work this out, of course here we get 15 degrees. So we have 15 degrees here, 15 degrees here. Question 13. At the beginning of 2009, Mr. Veal bought a company. The value of the company was £50,000. Each year the value of the company increased by 2%. We have to calculate the value of the company at the beginning of 2017. We have to give your answer correct to the nearest £100. So from 2009 to 2017, this is 8 years. So if we calculate the value of the company at the beginning of 2017, we've got 50,000, the original amount, multiplied by 1.02 to the power of 8. So if we work this out, we've got 50,000 multiplied by 1.02 to the power of 8. It turns out here we get a value of 58582.96, etc. So to the nearest £100 we have 58600. And now for the next part of the question. At the beginning of 2009, the value of a different company was £250,000. In 6 years, the value of this company increased to £325,000. This is equivalent to an increase of X% each year. We have to find the value of X. And we have to give our answer to two significant figures. So we've got our original amount, £250,000. Our multiplier here will be 1 plus X over 100. And we're investing, well, from 2009, and then we've got 6 years. So our time frame is 6 years. And at the end of it all, we get 325,000. So if I divide through by £250,000, we've got 1 plus X over 100 to the power of 6. If we work out what this is, we've got 325,000 divided by 250,000. It turns out we get 1.3. And if we take the 6th root of this, we've got 1 plus X over 100 equals the 6th root of 1.3, which is 1.04, etc. And subtracting 1 from both sides and then multiplying by 100, you will find X to equal 4.469, etc. So therefore, to two significant figures, we've got X equals 4.5. Question number 14. We have to shade on the grid the regions that satisfy these inequalities as we see here. So we've got y being greater than 1, x plus y being less than 5, and y being greater than 2x. So what we can do, if we grab a dashed line, and the reason we want a dashed line is because we've got a strong inequality. If we begin with y being greater than 1, well, let's draw the line of y equals 1. That looks something like this. So here we've got the line y equals 1, and we want everywhere above that, so the region we want is everything above this line. We'll deal with that later. And then we've got the x plus y being less than 5. Well, let's draw the line x plus y equals 5. It passes through 5 on the y-axis and 5 on the x-axis. So here is the line x plus y equals 5. And if I draw the line y equals 2x, well, we've got a gradient of 2. So here, we have something looking like this. Okay, so let's just extend this line over here. Gradient of 2, of course. Here is our line. So now we want the region above y equals x plus 1, so that's everything here. We want the region where x plus y is less than 5. So that's over here. Rather, yeah, that's over here. And we also want the region where y is greater than 2x, so that is over here. So this is the region which we want. Okay, so now if we complete the shading, here is our graph. Okay, so this is exactly what we want to shade. So this is our required region, and we need to label this region R. So let's label the region R, and of course let's label this line y equals 2x. Question number 15. Tracy is going to choose a main course and a dessert in a cafe. She can choose from 8 main courses and 7 desserts. Tracy says that to work out the number of different ways of choosing a main course and a dessert, you add 8 and 7. Is Tracy correct? You must give a reason for your answer. Well, clearly here we need to use the product rule of counting, and of course if we do that we need to multiply the 8 and 7 to give 56, so she's incorrect. So you multiply the 8 and 7 to give 56. And now for part B, 12 teams play in a competition. Each team plays each other team exactly once. We have to work out the total number of games played. So here we've got 12. That's how many teams we've got. And then we have to multiply this by 11. And that's because each team can't play itself. And then of course we need to divide this by 2. And the reason we divide by 2 is because each player plays each other exactly once. So here we get 66. So we get 66. Question 16, we have to solve x minus 2 all squared equaling 3, giving our answer correct to 3 significant figures. Well, first of all, if we square root, we would have x minus 2 equals plus minus square root 3, and therefore x equals 2 plus minus square root 3. So if we work the value of this out, we've got 2 plus root 3, which is 3.73, etc. And if we work out 2 minus root 3, we get, as a decimal, 0.26, etc. So therefore, to 3 significant figures, you will find we get 0.27, rather we've got 0.268. So we've got x equals 0.268, and we've also got 3.73, both given to 3 significant. Question 17. The table gives information about the heights of 150 students. So we've got the height given as an interval and the frequency. And for part A, we have to draw a histogram for this information. Well, what we can do before we do anything else is work out the cumulative, we can work out the class width. So here we've got 10, then 5, then 5, then another 5, and then a 15. And then for the frequency density, we've got 1.5 here because we've got 10 divided by 15, which is 1.5. Rather, explain where we got this from. We should know already that frequency density multiplied by class width gives frequency. We're finding out frequency density, so that's frequency over class width. 15 divided by 10, that's 1.5. 30 divided by 5, that's 6. 51 divided by 5, that's 10.2. 36 divided by 5, that's 7.2. 18 divided by 15, that's 1.2. So now we need to plot all these. So let's just grab a ruler and make the lines vertical. So first one, we've got class width of 10, frequency density of 1.5. Well, our maximum frequency density, you can see, is 10.2. And if you look at the number of squares we've got 1, 2, 3, 4, 5, 6 whole squares. So here we've got 0. Then we've got 2, 4, 6, 8, 10, and then 12. And in terms of the class width, well, we're going from 140 to 180, so here we can, if I start this one at 0, then here we've got 140, 150, 160, 170, 180 and 190. So first one we've got is class width of 10, frequency density, we found that to be 1.5. So we've got 1.5, which is over here. So we'll leave that alone for a second. Actually, let's just add in the horizontal line. So here we get this. For the next one, we've got class width of 5 and frequency density of 6. So frequency density of 6 and then a class width of 5. That takes us up to here. And then for the next one, we've got a class width of 5 and a frequency density of 10.2. So 10.2, well, we've got 10.2, which is over here. And then for the next one, again, class width of 5, and then frequency density is 7.2. So for the next one, we've got 7 over here, and then 7.2 goes here. So if I draw a line across, we get this. And then we've finally got 1.2 with a class width of 15. So the 1.2, that goes over here, and that takes us up to the 180. So now all we have to do is join all these up with a straight line. So if we do that, we've got something, well, let's just rub this out. So if I draw a vertical line, we've got something looking like this. Okay. And then now if we draw the next one, we've got this, and then we've got going from here, going down, and then we've got this, and then finally we've got this. So this is our histogram. And now for part B, we have to work out an estimate for the fraction of the students who have a height between 150 centimeters and 170 centimeters. So in terms of what we're looking for, so we want all of this over here, that's shown in red. So, well, here we've got, for this first part, between 150 and 155 we've got 30. So in terms of the fraction, we've got here 30, and then we've got here for the next one 51, and then we've got for the next one over here for the third bar, that's 36, and for the next one we've got a frequency density of 1.2 and then a collapse width of 5. So here we've got 5 multiplied by 1.2, and in total we've got 150. So if I work all of this out, it turns out we get 123 over 150, which is 41 over 50. So here is what we've got. We've got 41 over 50. Question 18. At time t equals 0 hours, a tank is full of water. Water leaks from the tank. At the end of every hour, there's 2% less water in the tank than at the start of the hour. The volume of water in litres in the tank at time t hours is Vt, and given that V0 is equal to 2000 and Vt plus 1 is equal to k lots of Vt, we have to work out the value of k. Well, this t plus 1 over here tells us that we're considering the time after each hour. And if we have 2% less, this tells us as a multiplier, we've got here 98% left each hour. And obviously this would correspond to the value of k. So therefore k is equal to, as a decimal, 0.98. Question number 19. A triangle has vertices P, Q and R. The coordinates of P are -3, -6. The coordinates of Q are 1, 4. And the coordinates of R are 5, -2. M is the midpoint of PQ. N is the midpoint of QR. We have to prove that MN is parallel to PR. You must show each stage of your working. Well, I think to begin with, it might be a good idea to draw everything on a diagram. So here we've got the diagram of the triangle PQR, and I've added on the coordinates of M and N, which are the midpoints of PQ and QR respectively. But we don't know these coordinates, but we can work them out because we're told that M is the midpoint of this line and N is the midpoint of this line. So if we work out the coordinates of M, we've got here -3 plus 1 over 2 for the x coordinate, and for the y coordinate we've got 4 plus -6 over 2. So if we work this out, you can see the coordinates of M are, well, on the top we get -2 over 2, which is -1, and coordinates of the y coordinate will be -2 over 2, which is -1. So M has coordinates -1, -1. Let's do the same thing with N. N, if we work out the coordinates of this, we've got 1 plus 5 over 2, so we've got 1 plus 5 over 2 for the x coordinate, and then for the y coordinate we've got 4 plus -2 over 2. So therefore N has coordinates 3, 1. So if we add this to the diagram, we have 3, 1. So now that we know the coordinates of M and N, well, let's think about what we need to show. We need to show somehow that PQ is parallel to MN. So to do this, we need to find out the gradient of MN and also the gradient of PR. The way we do this, well, gradient is equal to change in y, y2 take y1, over change in x, x2 take x1. So if we find out the gradient of PR, so gradient of PR, that will equal, well, we've got change in y, so that will be -2 take away -6. So we've got -2 take away -6 over change in x, so that will be 5 take away -3. So if we work this out, we get 1/2. So the gradient of PR is equal to 1/2. And if we find out the coordinate, the gradient of MN, this is equal to, well, here, change in y, we've got 1 take away -1. Change in x, we've got 3 take away -1. So of course here we get 1/2 as our gradient. So the gradient here is equal to 1/2. You can see we've got the same gradient, and therefore they will be parallel. So because we've got equal gradients, we can conclude that these are parallel. Question 20, we've got OAC, which is over here, which is a sector of a circle, and the radius is 10 meters. BA, that's a tangent to the circle at the point A, and BC, that's a tangent to the circle at the point C, and the angle AOC, that's shown here, is 120 degrees. We have to find the area of the shaded region. So to do this, well, what we can first of all recognize is that the radius and the tangent are perpendicular to each other. So that means that this angle here is 90 degrees, this angle here is 90 degrees, because the tangent is perpendicular to the radius. So we've got the angle here and here being 90 degrees because the tangent is perpendicular to the radius. So with this, we can find out the angle ABC, that's over here. So we should know that angles in a quadrilateral sum to 360, so therefore the angle ABC, that's equal to 360 take away 90, take away 90, take away the 120, which is 60. So that means this angle here is 60 degrees, and that's because angles in a quadrilateral sum to 360 degrees. So we've got 60 degrees here, and if I split this shape up into two equal parts like this, then because this angle is 90 degrees, and we know already that angles in a triangle sum to 180, and we also know that this side here is 10 meters. That means here we've got an isosceles triangle for AOC, so that means this angle here is 180, rather 180, take away 120 divided by 2, which is 30 degrees. So we've got 30 degrees here, and we've also got 30 degrees here. So we've got 30 here and 30 degrees here. The reason is because AOC is an isosceles triangle, so let's just write that down. So AOC is isosceles, and therefore OAC is equal to OCA, which is equal to 180 take away the 120 over 2, which is equal to 30 degrees. And that's because base angles in an isosceles are equal. So therefore, the angle over here will be 90 take away 60, which is 60. So we've got 60 degrees here. So here we've got 60 degrees, and we've also got 60 degrees here. So let's just write down the reason for that. BAC, so BAC equals BCA, which is equal to 90 take away the 30, which is equal to 60 degrees. And because that's equal to 60 degrees, we can therefore conclude that the triangle ABC is an equilateral. Okay, so here we've got an equilateral triangle. Okay, so that means that AC is equal to AB, which is equal to BC. Now we can actually find out what AC is using the cosine rule. We've been given two lengths and an angle in between those. So therefore, AC squared is equal to, if we work this out, we've got 10 squared plus another 10 squared minus 2 times by 10 times by 10 times by the cosine of 120, which is 300, and therefore AC, which is also equal to AB, which is also equal to BC, as we stated here, is equal to the square root of 300, which is 10 root 3. So we've got 10 root 3 here, we've got 10 root 3 here, and we've also got 10 root 3 here. So now what we can do is find out the area of each of those triangles. We've got a triangle here and a triangle here. So triangle ABC, the area of triangle ABC, we've got 1/2 times by the base, we've got 1/2 AB sine C, so we've got a half times by 10 root 3 times by 10 root 3 times by the sine of 60 degrees. So if we work out this, we've got a half times by 10 root 3 times by 10 root 3 times by the sine of 60, which is 75 root 3. So we've got 75 root 3. So that's that triangle, and we can also find out the area of the triangle OAC. So therefore the area of the triangle AOC, that will equal 1/2 times by 10 times by 10 times by sine of 120. This will equal 25 root 3. And therefore the area of the shape OABC, that's equal to the sum of these. So we've got 75 root 3 plus 25 root 3, which is 100 root 3. So we've got 100 root 3 for the total area. Now let's find out the area of the sector. So therefore the area of the sector, we've got a proportion of a full circle, so we've got 120 over 360. Times by pi times by 10 squared. So it turns out here we get 100 pi over 3. And don't forget the units. We've got meters squared. Okay? And of course here we've got meters. So we need to find out the shaded area. So therefore for the shaded area, we've got 100 root 3 minus 100 pi over 3. So if we work this out, we've got 100 root 3 minus 100 over 3 times by pi, so we get 68.4 etc. meters squared. And if we want this to 3 significant figures as stated in the question, if we round this to 3 significant figures, we get 68.5 meters squared. Of course, to 3 significant figures. Question number 21. There are 12 counters in a bag. There is an equal number of red counters, blue counters and yellow counters in the bag. So this means over here that there are 4 red, 4 blue and 4 yellow in total. Okay, so this statement tells us that there are 4 red, 4 blue and 4 yellow in total. And there are no other counters in the bag, and 3 counters are taken at random from the bag, and we have to work out the probability for part A of taking 3 red counters. So we're finding the probability of finding a red, another red and another red. Well, over here there's 12 counters in total, and of those 12, 4 are red. That's our first pick. For the next pick, if we've already picked a counter, there's 11 left, and we've already picked a red, so there's 3 red left. So this is our second pick. And for the third pick, there'll be 10 counters left, and we've already chosen a red, so if we choose another red, there'll be 2 left over. And if we work out what this is, it turns out 4 times 3 times 2 is 24. On the bottom we've got 1320, which we can simplify to 1 over 55. So the probability is equal to 1 over 55. And now for part B, the 3 counters are put back into the bag. Some more counters are now put into the bag. There is still an equal number of red counters, blue counters and yellow counters in the bag. There are no counters of any other colour in the bag. 3 counters are taken at random from the bag. It is now less likely, or is it now less likely or equally likely or more likely that 3 counters will be red? You must show how you get your answer. So, if we think about it, we already know from part A that the probability of selecting 3 red is equal to 1 over 55. Let's just write that down. So from part A, the probability of selecting 3 red is equal to 1 over 55, and this was with having 12 counters in total. Now we're adding more counters into the bag. So let's suppose we add one more counter of each colour into the bag. So if you add one more of each colour into the bag, then that means we have a total of, well, we've got 12 originally plus 3, which is 15. So we've got 15 counters in the bag, and therefore we've got 5 red, 5 blue and 5 yellow. And the reason we've got this particular number is because there is still an equal number of counters in the bag. So that's why these are equal. Now this time, if we take 3 counters from the bag of the same colour, so this time if we work out, so well, now with the increase, if we now work out the probability of getting 3 reds, this is equal to, well, we've got 5 over 15, and then we've got 4 over 14 multiplied by 3 over 13. So if we work out this total, we get 60 over 2370, which is 2 over 91. So this is if we add one more of each colour. And what you can see over here, if we work out what 1 over 55 is, 1 over 55 as a decimal, that's 0.018, etc. And 2 over 91, that's 0.02, etc. So obviously this value over here is larger than this one. So the 2 over 91 is greater than the 1 over 55. You can find the decimal equivalents as I've just shown. So the probability of choosing 3 reds increases as you add one more of each colour, and therefore we are more likely. Question 22. The functions f and g are such that f of x is equal to 5x plus 3 and g of x is equal to ax plus b, where a and b are constants. G of 3 is equal to 20 and the inverse of f at the point x equals 33 is equal to g of 1. And we have to find the value of a and find the value of b. Well, first of all, we're given that g of 3 equals 20. So with that information, if we have g of 3 equaling 20, that means we've got a lots of 3 plus b equals 20. In other words, we've got 3a plus b equals 20. Now let's find the inverse of f and then substitute that into substitute 33 into that. Well, first of all, we replace the f with y, so we've got y equals 5x plus 3, and if we swap the x and y, that means we've got x equals 5y plus 3, and if we rearrange for y, you can see y is equal to x minus 3 over 5, and therefore the inverse of f is equal to x minus 3 over 5. Now if we find out what g of 1 is, you'd find g of 1 to equal, if we work this out, rather before we do that, let's work out what the inverse of f is at the point x equals 3 is. So we've got 33, take away 3, over 5, so we've got 30 over 5, which is 6. So the inverse of f at the point x equals 33 is equal to 6, and this is equal to g of 1. So therefore, g of 1 is equal to 6. So g of 1 equals 6. This means we've got a lots of 1 plus b equals 6. In other words, a plus b equals 6. And our job is to find out what a and b are. So if I call this equation 1, and if I call this equation 2, we will be solving equation 1 and 2 simultaneously. And because the number of b's are the same, we can subtract the equations. So if we do equation 1, take away equation 2, 3a take away a, that's 2a, b take away b, that's 0, 20 take away 6, that's 14, so 2a is equal to 14, a is therefore equal to 7. And with a equaling 7, we can find out what b is by substituting into equation 2. So we've got 7 plus b equals 6, b is equal to minus 1. So we have a equals 7, b equals minus 1. Question 23. S is a geometric sequence. For part A, we're given that root x minus 1, 1, and root x plus 1 are the first three terms of S. We have to find the value of x showing our working. So, with a geometric sequence, of course, this is of the form un equals a, the first term, multiplied by r to the power of n minus 1. And rather, if we just move this here, a over here is the first term, and r over here is the common ratio. Then obviously r must remain the same between the terms. So we've got our first term, our second term, and our third term. So if we divide those terms, that should equal r. So r, the common ratio, is equal to, well, here we've got the second term over the first term, so we've got 1 over root x minus 1. This is equal to the third over the second, so here we've got root x plus 1 over 1. And our job is to find out what x is. So to find out what x is, we need to cross multiply. So we've got here 1 times by 1 equals root x plus 1 lots of root x minus 1. So we've got 1 equals, here we've got a difference of 2 squares, root x times root x, that's just x, and then 1 times minus 1, that's minus 1. So therefore you can see x is equal to 2. So we have x equals 2. And now for part B, we have to show that the fifth term is 7 plus 5 root 2. So if we substitute back into here, un is equal to a, the first term, which is root x minus 1, multiplied by the common ratio, 2, and we're raising this to the power of n minus 1. Okay? And we're finding out the fifth term, so we're finding out u5. u5 is equal to, rather here, during my mistake, un is equal to the first term, which is root x minus 1, so we've got root 2 minus 1. So this is the first term, multiplied by r, so r over here is equal to root 2 plus 1. Okay? So here we've got root 2 plus 1 to the power of n minus 1. So here we've got the first term, here we've got the common ratio. And our job is to find out what u5 is. So u5, that's equal to root 2 minus 1 times by root 2 plus 1 to the power of 5 minus 1. Now let's see if we can substitute this into our calculator. We've got root 2 plus 1, and we're raising this to the power of 4. Now here we get a decimal, so we need to be a bit careful in terms of how we work things out. So what we can do over here is recognize, well, here we've got root 2 minus 1, and then here we've got root 2 plus 1 to the power of 4. So if I work out root 2 plus 1 to the power of 2, I get 3 plus 2 root 2. So what I can do over here is recognize that root 2 plus 1 to the 4 is the same as root 2 plus 1 all squared to the power of 2. So we get root 2 minus 1 times by 3 plus 2 root 2 squared. So this bit inside this bracket is equal to this bit over here. And now if I square this, I get over here root 2 minus 1 lots of 17 plus 12 root 2. So now if we work this out, we need to multiply this by root 2 minus 1. So it turns out here we get 7 plus 5 root 2. No need to manually calculate everything because we've got our calculator. It's a calculator paper, so hence shown.